There we go. Hello everyone, this is Professor Wells, and today we're going to go over chapter 16, which reviews what gypsum is and the kinds of wax products that we use in the office. So what is gypsum? Gypsum is a mineral that's widely found in nature, and it's composed of the dihydrate of calcium sulfate. It's ideal for making diagnostic casts, working casts, and dyes. The production of gypsum casts requires meticulous attention to detail. Inaccurate or incomplete casts are often of little use to the dentist. Chemically, the mineral gypsum is a dihydrate of calcium sulfate. Gypsum is mined in a solid mass and then is ground into a powder called hemihydrate. This process is called calcination. When a hemihydrate is mixed with water, it becomes a flowable mixture. An exothermic chemical reaction, you guys all remember what exothermic means, right? Produces heat. So an exothermic chemical reaction occurs and the material hardens. The amount of water required to mix is greater than the amount required for the chemical reaction. This excess water produces a mix that can flow into the details of an impression and then evaporates on setting, producing a mass of interlocking gypsum crystals. Even though gypsum is always basically the same, different dental plasters are formed according to how the material is processed. If the material is heated in open vats at approximately 115 degrees Celsius, the resulting hemihydrate is porous and irregular in shape. This process will form a model plaster. If the heating process is done under pressure in the presence of steam and at a high temperature, a more uniformly shaped and less porous form of hemihydrate is produced. This is referred to as dental stone. A further increase in pressure and heat will produce a material called a dye stone. Even though there are differences in the three types of stone, their accuracy of each relies on the accuracy of the impression from which they're poured. Their use depends on which gypsum material is used and the properties of the material. This figure here shows a couple things made with gypsum. So right here, the model in white is a diagnostic cast. So this is used, a lot of times the dentist will look at it to determine treatment. We can actually show the patient what we're talking about as far as treatment goes for them. And then over here in the pink and the yellow, that's a working cast with a stone base. So the yellow is the stone base. And then the high strength stone, which is the pink stone here, for the anatomic portion. And right here at the very bottom of the picture, where's my mouse? Right here, that is a die, and this is made from the high strength stone, and it's got metal plating there. So it looks like what they're doing here with the working cast is they're getting ready to make a crown. So the missing tooth right here, the impression would show the prepped tooth structure, and from that poured model, they can create a crown that's going to fit into the occlusion. It's going to fit on the mesial and distal, so it won't be too big. So it's very, very important that the impression that is taken is as accurate as possible. Gypsum is manufactured as a plaster, stone, and high-strength stone. The main difference in physical forms depend on the variations in size, shape, and porosity of the powders. The larger, more irregular and porous the particles of powder, the weaker and less resistant to abrasion the final product becomes. Factors that affect the strength of gypsum products also affect their hardness. For example, diagnostic casts are placed under little stress and are usually produced from less expensive materials such as plaster or stone, both which have lower properties of strength and abrasion resistance. Working casts and dyes require materials resistant to greater stresses and will require higher properties of strength and abrasion resistance and precise accuracy, so setting expansion must be carefully controlled. Factors contribute to the strength and abrasion resistance of the final product are the shape of the particles and their porosity, and how much water is needed to mix. The factors that affect the strength also affect the hardness of the material. Increased porosity of the particles make it necessary to use more water to convert the hemihydrate particles back to their dihydrate particles. The increase in water will also increase the setting time and reduces the strength and hardness of the set gypsum. Setting expansion occurs with all gypsum products. Plaster has the highest rate of expansion and high-strength stones have the lowest rate. Setting expansion is the result of growth of crystals as they join together. Some expansion is acceptable, but large amounts of expansion will keep the end result from fitting. Setting expansion occurs only during hardening of the gypsum, and it's important to control this. The greater the porosity of the final gypsum product, the less surface detail that is produced. Even products that have the least amount of porosity have surface irregularities visible at the microscopic level. Set gypsum products are not highly soluble in water. Solubility is directly related to the porosity of the material. Therefore, plaster is much more soluble than stone. Exposing models to water for prolonged periods of time should be avoided. The desired physical properties and the behavior necessary for a particular use determine the criteria for selection of the gypsum product. They are classified into 5 different categories: impression and model plaster, dental, high strength, low expansion, and high strength, high expansion stone. Impression plaster is rarely used anymore. It can be used to mount cast onto an articulator, and an articulator is a mechanical device that's used to place the maxillary model and the mandibular model in occlusion on a fixed appliance. Model plaster is frequently used for diagnostic cast and articulation of stone cast. It's traditionally produced white in color to distinguish it from dental stones. Let's see here. If you're pouring up diagnostic models, plaster is typically used as it's least expensive of all the gypsum products. Dental stone type 3, which is usually colored yellow or white, is usually used to make an appliance such as orthodontic retainers, whitening trays, sports guards, and partials. It has a uniformly shaped, relatively non-porous crystal and requires less water to mix, making the material more dense. It's approximately 2.5 times stronger than plaster. If you're making a crown or a bridge, the high-strength, low-expansion dental stone would be used. It's often referred to as dye stone or densite because they are well suited for fabricating wax patterns for cast restorations. These products require very strict and detailed handling and are often colored pink or green and are almost 2 times stronger than the type 3 stones. Type 5 is a recent addition and was developed in response to the need for an even higher strength, higher expansion dental stones and materials that can withstand the high temps required for the casting process. The addition of silica improves the resistance to heat and gives it an increased thermal expansion. These materials are often referred to as gypsum-based investments and are blue or green in color. They are also the most expensive. Selection of a gypsum product should be based on the desired properties of the material. It is important that the mix have sufficient flow to reproduce details of the impression. Water should be measured with a graduated cylinder, and powder should be weighed on a scale. Too much water will make the mix weak. Too little water and the mix will not flow. Most commonly, plaster and stone are mixed in a flexible rubber bowl with a broad metal spatula. Mechanical devices are used when control of spatulation is critical. If you look on page 292 in your textbook, it goes over the steps on how to mix gypsum if you need to reference this. It's a good idea to go over it because this is what we're going to be doing quite a bit of in lab after fall break. The first step is to add the water to the bowl. Sift the powder into the water and mix with a broad spatula and spatulate the material until smooth. It's important that the powder goes into the water and the water not to the powder. It takes about 1 minute to mix the material thoroughly. After mixing for 1 minute, the working time begins. During this time, the semi-fluid mixture is poured into the impression with the help of a mechanical vibrator. After mixing, about 5 minutes of working time is available. As the viscosity of the mixture increases, the flow characteristics will decrease and the product loses its glossy appearance. This loss of gloss indicates that the gypsum has reached its initial set. The final set is reached once the material is hard and the exothermic reaction cools completely. Most manufacturers recommend that about 1 hour should pass before the impression is separated from the cast. If the impression is removed too soon, the model or the teeth will break. If left too long, the impression will dry out and will possibly snap off the teeth when you try to remove it. It's impossible to accelerate the final set of a mixture without also accelerating the initial set, thereby reducing the working time. The diagnostic and working cast have two parts: the anatomical portion that replicates the hard and soft structures, and the art portion aids in handling and articulating the cast. The anatomic portion is poured by vibrating small increments of flowable gypsum into the impression. The mixture should be poured slowly in small increments under vibration and allowed to flow from one tooth impression to the next, pushing out air ahead of itself as it fills the entire impression. This will eliminate air voids. This double pour technique involves 2 separate mixes and 2 separate setting times. The anatomic portion of one or both arches is poured and is left in the upright position. Approximately 10 minutes after the loss of gloss, a second mix is produced for the art portion. This mixture is placed on a glass tile or in a base former. The filled impression is inverted onto this base and the peripheries of the 2 portions are joined. In lab, we won't be doing the double pour method, we'll just be doing the single pour. So in the single step method, 1 mix of gypsum is produced to pour the anatomic and the art portions of the cast. After the impression is poured, the remaining material is used for the base. This material is placed on a glass tile or in a base former. The impression is inverted onto it and the peripheries of the 2 portions are joined. In the boxing method, a strip of wax is used to surround the impression, forming a wall into which the gypsum is poured. The wax should not distort the impression. It should extend at least 0.5 inches higher than the highest point of the impression and create a base that is parallel to the occlusal plane. Since gypsum products can absorb water from the environment, it should not be kept in humidity in close proximity to water sources, as it will adversely affect the powder. Gypsum should be stored in an airtight, moisture-proof container. Gypsum mixing and handling equipment must be kept meticulously clean. Set gypsum particles mixed with fresh gypsum will accelerate the setting times of a mixture. So when you guys are cleaning the rubber bowls that you use to spatulate the gypsum in, it's very important that you get as much of the powder out after you use it, because those little tiny particles can increase the setting times. Routine disinfection of impressions should be done in the dental office. Disinfection of impressions is the best way to prevent the introduction of contaminants into a laboratory area. If disinfection of the impression is not done, casts can be sprayed with cavicide only after it has set for 24 hours to prevent attack by the chemicals on the surface of the cast. On setting of gypsum, the impression tray and the cast must be separated. When the impression is poured, care should be taken to make sure the gypsum does not flow onto the tray, locking it into the set gypsum. To separate the model from the impression, you can take a lab knife and lift the tray slightly in several different areas. You can also carefully pull the model off with your hands, making sure that you do not tilt too far in one direction, or the force in that direction can cause the teeth on the model to break. Models are trimmed with a model trimmer to produce an attractive, symmetrical model with easy access to all the anatomical portions of the model and a base of sufficient bulk and stability. Bases made from dental stones should be soaked in water for 5 to 10 minutes before trimming to saturate the stone, making it easier to trim. The cast should be trimmed so that the proportionality of the base makes up 1/3 of the anatomic portion, 2/3 of the total depth. Please take a look at page 298 and 299 in your book. This goes over the correct way to trim a model. I'll also be showing a video in lab before we do this. So the base should make up 1/3 of the depth and the anatomic portion should be 2/3 of the depth. The occlusal plane should be parallel with the base. The anterior portion of the maxillary arch is trimmed to a point at the midline, and the anterior of the mandibular arch is rounded from canine to canine. There is also a nice picture in your book on page 286 that shows the proper way to trim a model and the landmarks for measuring where the cuts should be made. Cast used to make whitening trays are trimmed down much further than traditional cast, and symmetry is not a concern with cast used to make whitening trays. Type 4 and 5 gypsum are commonly used for dye materials. They are very hard, but they are susceptible to abrasion during carving of wax patterns. Investment materials, which combine gypsum and silica, are able to produce models sufficiently strong to allow molten metal to be poured into them. This is called the lost wax technique. I'll post a video about this in your module so you can view this. This is something that a lot of the dental labs do. So please make sure you take a minute to view that. Dental waxes are composed of a mixture of components from natural and synthetic sources. Natural waxes are produced from plants used in carnauba wax, insects used in beeswax, and minerals used in paraffin and saracen wax. These natural waxes contribute properties to the wax, but they are rarely used in their pure form. Flow is the movement of wax as molecules slip over each other. The control of the flow and melting point is important in manipulation. It's important that all the wax be removed from the object onto which it's melted. If the excess residue remains after the wax is removed, this could result in inaccuracies in the object that's being produced. Waxes expand when heated and contract when cooled. The thermal expansion and contraction of waxes are greater than those of any other dental material. This property is especially important for pattern waxes. If a wax is heated too far above the melting range or is heated unevenly, expansion of above acceptable standards will result. Waxes are classified into 3 categories. There's pattern waxes, processing, and impression waxes. They are produced in many forms, such as sticks or sheets, which can be used in a lab to take the bite registration, and also in blocks. Inlay waxes are used to prepare patterns for metal casting through the lost wax technique. They may be used directly in the mouth, which is type 1, placed onto the prepared tooth in the direct waxing technique, or more frequently melted onto a die outside of the mouth in the indirect technique, which is type 2. This first picture shows an inlay waxing on a die model. Casting waxes are used to construct the metal framework for partials and complete dentures. These waxes come in sheets and preformed shapes. The physical properties of casting waxes are similar to those of inlay waxes, with the exception of the melting range. Base plate wax is used mainly to make occlusion rims and to hold artificial teeth into the base plates during the fabrication of dentures. Base plate wax is composed mainly of beeswax, paraffin, and coloring matter, which are mixed together, cast into blocks, and then rolled into sheets. This other picture here shows a denture setup on a base plate. The boxing wax limits the flow of the stone or gypsum material. Boxing wax is usually issued in red strips measuring 1.5 inches wide and 12 inches long, and about 1/8 of an inch thick. Boxing wax is soft and pliable enough at room temperature to be formed into the desired shape without heating. Utility wax is used to provide rim locks and otherwise to adapt impression trays for individual impressions, to build up post-dam areas on impressions, and to form a bead or border on preliminary or final impressions. Utility wax is pliable enough at room temperature to be used without heating. It's also normally issued in stick form and is usually red. Sticky wax has the property of adhering to the surfaces of various materials. It's composed of beeswax, paraffin, and resins. Corrective impression wax is used in conjunction with other impression materials in the process of taking edentulous impressions. This wax flows at mouth temperatures and is used to correct undercuts. Bite registration wax is used to produce wax bite registrations for articulation of models. They come in sheets or preformed horseshoe shapes that are often reinforced with metal particles to provide stability. When using wax, you should first soften it so it's not brittle. You can use an even dry heat, warm water, flame, or even just your hands. Wax should be stored at or slightly below room temperature to avoid distortion. Artisans have used the lost wax technique for several hundred years. In the 1500s, artisans in conjunction with medical practitioners invented a method for casting gold for dental restorations in molds. Today's techniques are much the same. The primary steps in the lost wax technique and casting are pouring the dye, waxing the dye, spruing the dye and attaching it to a sprue base, investing the wax pattern and burning the wax out, casting the restoration, and then the final steps where the metal is cooled, sprue removed, and casting is cleaned and polished. On page 289, it goes into a little more detail on each of these steps, so make sure you review that because this will be something you will see on possibly a quiz or a test. In summary, gypsum products are used to produce many kinds of models. You have the occasion to use gypsum and dental waxes in a variety of clinical procedures, so making sure you know the basics of the material is very important. The gypsum material's properties of strength and hardness, setting expansion, and solubility are directly related to the amounts of water used in construction. So taking impressions is something you guys are able to do. You will help the dentist out. A lot of times after he comes in and does the exam, he may say, oh, let's make some whitening trays, and the patient agrees to it. So if you have time, you're doing the dentist a favor by taking those impressions and being able to pour those models as well. Plus the assistants will like it even better. So once again, if you guys happen to have any questions over the material in this chapter, please feel free to reach out. My email is hwells14@ivtech.edu.